eliminate y or z from these equations. I think the easiest thing to do, in my opinion, is to solve for y here. So if I get y is equal to what? Y is equal to 1 minus x minus 3z divided by 2. Well, and then I can square it, right? If you take that and you square it, what do you get? You get 1 minus x minus 3z quantity squared divided by 4. That's y squared. But what else is y squared? Yeah, 4 minus z squared minus x minus 1 squared. Now this equation is precious to us because it's got no y in it, and it's just got x and z, right? So if we've chosen x to be our parameter, basically x equals to t, that means I can solve this. I can try to solve it at least. So here we go. This is 1 minus t minus 3z, and let's see here. Yeah, I got to say that squared is equal to, I'm going to multiply the 4 to the other side. That gives me 16 minus 4z squared minus t minus 1 quantity squared. Oh, thank you. I'll do that. And now I just need to solve for z, which I can do. Everything's quadratic. So 1 minus t quantity squared minus 6 times 1 minus t times z plus 9z squared is equal to 16 minus 4z squared minus 4 times t minus 1 quantity squared. So this is quadratic. You can solve for z. You can solve for z as a function of t. It's unpleasant, but it can be done. So what do you get? Z squared. What's the coefficient of z squared? I got 13z squared minus 6 times 1 minus t times z plus what? One of them here. I got 4 of them, so I get plus 5 times t minus 1 squared. And minus 16 equals to a 0. Quadratic. Z is equal to, 6 times 1 minus t plus or minus the square root of 6 times 1 minus t quantity squared. I'm getting tired of writing this out. Minus 4. It's your homework, not mine. I don't know. There may be an easier way to do this, though. And so forth. I mean, let me just stop here rather than wasting our time. The point is you have z as a function of time, right? You have x as a function of time, and then you can come back to this formula over here and then have y as a function of time. This will parametrize this circle in terms of time t. Is there a better way to do this? Almost certainly. This is a hard problem. There's almost certainly a more clever solution.
I solved it in a lot less steps.
Well, it was different.
Yeah, well, I solved the actual problem.
Mm-hmm.
I'm really excited about it.
Good. That's good. Now, I like his idea about the circle, right? So here's a more methodical way we could do it. If you chose vectors to fill out the plane, which were unit vectors and were orthogonal. If you build the plane using orthogonal unit vectors, then what that means is the parameters are actually distance on the plane. And if I did that, then I could take a circle in the domain of the parametrization for the plane, and it would map to a circle on the plane. It wouldn't do that ellipse thing that happened in the notes. So that's kind of a more systematic, more enlightened way of solving this problem. Find an orthonormal basis, an orthogonal length 1 set of two vectors on the plane and build a parameterization from the plane of those, which is centered at the point you want, and then just feed a circle, which has radius, whatever it is that you want in your problem, into that parameterization. The image under that parameterization will be the circle you want. That's the way you could do it without this tinkering. That's probably what I'll put in my solution when I write it. Okay? This is a place where you could find another way. I mean, there's just this, it's open-ended. This is the nature of parameterization. That's why some people ask me, how do you know what to parameterize? How do you know what to do next? I can't answer that question. Parameterization is an art. It's not something you can put in a box and say, well, this is how you do it in all cases. It's not like that. There's a creative process here that is not, you can't just dumb it down to, an algorithm. It's not like that. It's much more open-ended.
So in other words, it's not something you can do with computers.
Yeah, can you do it with a computer? Yeah. Probably, because computers can do what we're doing here. They can do this kind of thing much better than we can. But it's not enlightened. It's not like, these are much prettier than what we're doing over there, right? But where did these come from? Why did I think cosine squared plus sine squared? Why did I think cosh and sinh here? There's a creative leap writing those down. Other questions? Question. Does someone have to ask a second question? So I guess you can sell that solution for money. Gentleman in the back. Go talk to him for the easy solution.
I think I missed the step that I didn't write down. Now I'm trying to explain it.
Uh-oh. Oh, well, there's doubt. Sorry, I should stop doing that. It's cruel. I'll bring you guys some goodies soon, though, to celebrate us being done with the test 1 material. Woo! Well, I'm done with it. You're not done with it. But you will soon experience the ultimate form of classroom interaction. The test. Yes?
Are you gonna post the study guide, or is that the study that's been
Do the missions. And there's old tests, so you can look, you can see what's there. But you do get a 3x5 inch card, so think about what should be on there as you're doing the missions. And I can give you some general advice. We'll have a day for questions, so at least a day.
When is the census? Next Tuesday?
Yes, next Tuesday. Yes, sir.
Also, when are you posting the permissions due?
Hopefully soon after it's due. So
You said no calculator on the tests, right?
you can use a basic scientific calculator, but not a graphing calculator. No smartphones, obviously. There's this thing called the Wolfram Alpha app. It cannot be allowed. It's awesome, but it cannot be allowed. My brother has emulators for TI-84s and 89s on his, he's got a Galaxy, I don't know what it is, one of these Galaxy things, and he actually has full-size TI-89 emulator. Why would you buy a graphing calculator, But because someone told me to, I had to. Fair enough. I guess you guys aren't going to ask me any more questions because you want to leave. That's understandable. We have all of tomorrow for questions, so I'll see you then. You can hit it.